How to implement particle swarm optimization in code. Are you curious about how to implement particle swarm optimization in your coding projects? This optimization method is inspired by how birds flock or fish school, and it can be a game changer in robotics and automation. Let's break it down step by step. First, you need to initialize the swarm. This means creating a group of particles where each particle represents a potential solution to your problem. Each particle has a position vector, which shows where it is in the solution space, and a velocity vector that tells it how fast and in what direction to move. You will also track each particle's personal best position, which is the best solution it has found so far. Start by randomly placing these particles within the defined boundaries of your problem, and set their velocities to 0 or small random values. Next, you will define the objective function, also known as the fitness function. This function measures how good a solution is. In the context of robotics, it could evaluate factors like error rates, energy consumption, or the distance to a target. The goal of particle swarm optimization is to either minimize or maximize this function based on your needs. Now let's set the algorithm parameters. You will need to decide on several important values. First, determine the number of particles, which is known as the swarm size. Then, set the maximum number of iterations, which is how long the algorithm will run. The inertia weight controls how much influence the previous velocity has on the current velocity. The cognitive coefficient measures how much each particle is drawn to its own best position, while the social coefficient measures how much it is drawn to the best position found by the entire swarm. Once you have everything set up, it's time for the iterative optimization process. For each iteration, evaluate the fitness of each particle's current position. If a particle's current position is better than its personal best, update that record. Also, keep track of the best position found by any particle in the swarm. Update each particle's velocity using a specific formula that combines its previous velocity, its personal best position, and the global best position. Then, update each particle's position by adding the new velocity. Make sure the new positions stay within the defined bounds, adjusting if necessary. The process continues until you reach the maximum number of iterations or find a solution that meets your criteria. At the end, the global best position is considered the optimal solution. When coding particle swarm optimization, consider representing particles as objects or arrays that include attributes for position, velocity, and personal best. If you are using a language like Python, you can use libraries like NumPy for efficient calculations. Visualizing the movement of particles can also help you understand how they converge toward the best solution. In the field of robotics and automation, particle swarm optimization can be used for tasks like optimizing path planning, adjusting control parameters, or determining the best placement for sensors. Its ability to handle complex, multi-dimensional problems makes it a great fit for emerging technologies. If you want to see a simple coding example in Python, start by importing necessary libraries. Define your objective function, initialize the particles, and loop through the iterations to evaluate fitness and update positions and velocities. Finally, return the best solution you found. By following these steps, you can effectively implement particle swarm optimization in your projects, making it easier to tackle complex problems in robotics and automation.